Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to see question 6 of the difficult question series. So the question is, you can see here what is given to us is alkyne. Okay, so this is based on reaction of alkyne. Okay, alkyne, and this is the trans diol. You can see this is above the plane, this is below the plane. So we can call this product as trans, and then two alcohol groups are present, so this is called as trans diol. So the first thing that you can notice is here there are only two carbons, and here if you see in the product there are four carbons. So we have to do some organic transformation such that we can convert 2 carbon into 4 carbon. That is what we have to do, is we have to do chain lengthening reaction. So we start with alkyne. Okay, ethyne that is given to us. Okay, we know that these are what? These are acidic protons. Why? Because the hybridization of carbon is what? sp. Okay, we count what? We count the number of sigma bonds. Here there are 2 sigma bonds. So sp. For this carbon also there are 2 sigma bonds. So sp has what? 50% s character, and greater the percentage s character, we know greater is the acidity. Okay, so these are acidic in nature. So what we can do is we will first form the salt. So what we do is first we react it with some base, that is NaNH2. This is a very good base, sodium amide. What is the name of this? Sodium amide. Okay, why this is a good base? Because NH2 minus, if it picks up a proton that is H plus ion, what it will form? Ammonia. Ammonia is stable molecule. Okay, so what is the first step that we are doing? We are reacting both the acidic protons with this base. Okay, NH2 minus will pick up proton and we will get a salt. Similarly, this is also acidic, so this proton will also be abstracted, and what we will get is we will get a salt. Okay, carbon-carbon triple bond. This has one lone pair, that is negative charge, and here also there is one lone pair, that is negative charge. And this is what? This is a salt. So sodium is the counter ion. Okay, this is called as acetylide salt. Acetylide salt. And what is the next step? Now we want a 4 carbon chain, right? So this acetylide salt can act as a nucleophile. Okay, this can act as a nucleophile. So what we can do is we can react it with some alkyl halide. Let's say we want 4 carbons, right? So I can react it with, let's say, methyl iodide. Okay, here also, and here also it will react with methyl iodide. So this will attack here, and I minus will go away as a good leaving group. Similarly, here also there will be substitution reaction that is taking place. Which reaction this is? This is SN2 substitution reaction. Okay, what was the first step? This is the acid-base reaction or neutralization. Okay, second step what we are doing is here we are taking 2 equivalents. Okay, 2 equivalents of methyl iodide. So one can react with one terminal of the alkyne, and other methyl iodide can react with other terminal of the salt. So what we have got now is a 4 carbon compound. Now this is what? 1, 2, 3 and 4. So this is 2-butene. Okay, 2, because at the second position there is triple bond. Now here you can see there is some 2 alcohol groups that are attached. So first of all what we have to do, we have to introduce oxygen in this reaction. So what we can do here is, the first step what we can do is we can reduce this alkyne. You know, here it is what? It is an alkane. So first what we can do is we can reduce alkyne to alkene first. So which alkene we can reduce? Let's say we do reaction with Birch reduction, sodium in presence of liquid ammonia. Okay, what I will get? I will get transalkene. Right, I will get transalkene. CH3, C, double bond C, CH3, H and H. So now we have got an alkene. Now what we can do is we can introduce the oxygen. How we can introduce the oxygen? What we are going to do is epoxidation. Epoxidation means formation of a 3-membered heterocyclic ring, okay, by using this reagent, that is metachloroperbenzoic acid. Okay, what is the structure of this? Benzoic acid is this, C double bond O OH. Perbenzoic acid means here there is a peroxy linkage. Okay, then meta position there is chloro. So this is what, this is the reagent used for epoxidation. What is an epoxide? Epoxide is a 3-membered ring with oxygen as the heteroatom. Okay, so what is going to be the next step? Next step is going to be epoxidation. So let me erase this. Okay, so CH3, C double bond C, CH3, H, H. So what we are doing? We are doing epoxidation. So what we will get is, we will get a 3-membered ring. Let's say a 3-membered ring is formed above the plane like this. Okay, and then there are methyl groups and hydrogen. Okay, oxygen having 2 lone pairs. So now what will happen is, this is what, this is the epoxide that we have got, but what exactly we want is a trans diol. So what we will do is, next step is, the last step is going to be hydrolysis. Okay, H3O plus. What is the first step? First step is protonation. Okay, this lone pair is electron rich, it will attack hydronium ion. H3O plus is hydronium ion, and water will go away as a good living group. So first step is what? First step is protonation. CH3CH, oxygen having 1 lone pair, hydrogen positive charge, and here there is hydrogen and methyl. Now next step is, now water will attack as a nucleophile, intramolecular. Now this will be what? This will be again a substitution reaction. What? Oxygen having 2 lone pair. How this will take place? Now this will attack from the opposite side. This is called as anti-addition. Okay, anti-addition, that is from the exactly opposite side. Now above the plane you can see ring is formed, right? So this will attack from below the plane. Below the plane. So what we will get is, the final product that we are going to get is CH3CH. Now here there will be above the plane there is OH. Okay, then CH. Here from below the plane what has attacked? Water molecule, right? Last step will be, okay, last step will be water will pick up this proton and it will become alcohol. Okay, that is deprotonation. So what we are going to get here is OH and CH3. So you can see this is the final desired product, or we can say the target molecule that we had to prepare. Okay, so this is a good question. It's slightly lengthy, but so many reactions we had seen. So first what we did is acid-base reaction or neutralization. Right, second neutralization, we reacted alkyne with a base, that is NaNH2. Right, we reacted with NaNH2. Second step what we did was alkylation. Okay, that was what? That was substitution reaction, SN2 reaction. After this what we did? We got 4-carbon alkyne. Then we did reduction. Which reduction? Birch reduction. Right, Birch reduction, what we got in Birch reduction is transalkene. Okay, after this what we did? We did epoxidation. Okay, epoxidation or formation of epoxide. And last step what we did was reaction with, we did hydrolysis. Okay, reaction of water in presence of acid as a catalyst. Okay, so total of 5 different reactions we learnt during this organic transformation. 1, 2, 3, 4 and 5. Okay, so I hope you have understood all the steps and the mechanism of the reaction. Thank you.